Hello, this is the Section 4.7 lesson. In Section 4.7 we're going to talk about a type of problem that's called counting problems. Counting problems occur frequently in probability problems. They also occur frequently in other situations, so they're a very useful type of problem to study. For this lesson you're going to need your calculator. Our first example, suppose that a password for a website requires the user to select 3 letters from A, B, and C. Now of course this is a very simple password, but we got to start simple. Suppose the letters can be repeated, find the number of possible passwords. We could think of this as though we're selecting the letters with replacement. Because they can be repeated, we can think of those as though we're selecting one letter from the group A, B, and C, and then we replace it, select the second letter from those 3, and then we replace it and we select a third letter from those 3. So they could all be the same, and a letter could be repeated. So to solve a problem like this is an example of a counting problem. We just want to count the number of ways that something can be done. We're going to start off by drawing 3 blanks here. We draw 1 blank for each of our different choices that we have to make here. And then once I've drawn the blank, I ask myself, how many ways can each of those choices be made? So for the first letter, well, I have 3 possibilities. So I put a 3 there in that blank. For the second letter, well, I have 3 possible choices. So I put a 3. Likewise for the third. So that's the number of ways that I can make each one of those choices. Now to count the total number of ways to do this, I simply multiply those numbers 3 times 3 times 3, which comes out to be 27. So there's my answer. I have 27 different possible passwords in this scenario. Now example 2, we're going to look at a variation of this. Again, we're going to choose 3 letters from A, B, and C, but suppose the letters cannot be repeated. Find the number of possible passwords. We could think of this as though we're selecting without replacement. So I'm like I select one letter from A, B, and C, and then I do not replace that letter, and I select one from the remaining 2, and then I select a third letter from the remaining 1. So we're going to approach this in the same basic way. We're going to draw 3 blanks, 1 for each of our choices, and then I ask myself, how many different ways can I make those choices? Well, for the first letter I have 3 possible choices. It can either be A, B, or C. But now for the second choice I only have 2 possibilities, because I can't choose that letter that I chose for the first position. Now for the third choice I have only 1 possibility. Because I've already used 2 of the letters, there's only 1 left. So again, to calculate the total number of possibility, as I multiply these 3 numbers, 3 times 2 times 1 equals 6. So there's my number of possible passwords in this scenario. Now an arithmetic like this, where I take one number times the next smaller number times the next smaller number, comes up frequently in these counting problems, and so we give that type of arithmetic a special name. It's called a factorial. The factorial symbol, exclamation point, that's the symbol for the factorial, denotes the product of decreasing positive whole numbers. So as an example, 4 factorial is equal to 4 times 3 times 2 times 1, which is 24. The example that we just did, 3 times 2 times 1, would be 3 factorial. 9 factorial, for instance, would be 9 times 8 times 7, all the way down to 1, which comes out to be 362,880. A special case, by definition, 0 factorial is defined to be 1. That's a definition that doesn't fit the general rule. Definition 0 factorial is 1. Okay. Now factorials can be done very easily on your calculator. You don't have to type in all those numbers. You can simply enter the number that you want to find the factorial of, and then hit Math, which is on the left hand side of the keys towards the top, and then choose option PRB, which stands for probability, and then choose option 4, which is the factorial symbol. So there you see 9 factorial and its value. These first 2 examples illustrate what we call the fundamental counting rule, which is easier to show by example than it is to explain formally, but we're going to go ahead and state its formal statement. For a sequence of two events in which the first event can occur in m ways and the second event can occur in n ways, the events together can occur a total of m times n ways. In other words, we simply multiply the number of possible choices to get the total number of possible choices. Example 3 is going to be another fundamental counting rule problem. In a certain state, license plates currently consist of 2 letters followed by 3 digits. If the letters and digits can be repeated, how many such license plates are possible? Okay. So in this case, we have 5 choices to make. We have the 2 letters and then the 3 digits. So I'm going to draw 5 blanks there. The first 2 are for the letters, the last 3 are for the digits. And then again, I ask myself, how many ways can I make those choices? Well, I have 26 letters. I can choose all of them for the first position, and I can choose all of them for the second position, again because letters can be repeated. For the third position, I have 10 digits to choose from, and the same for the fourth and the fifth. So I multiply all those, 26 times 26 times 10 times 10 times 10, and 676,000 is my total number of license plates. Example 4, 14 boats enter the America's Cup yacht race. How many possibilities are there for the first through third place finishers? So here I have, I'm looking at 3 different places, the first place, second place, and third place, so I draw my 3 blanks. Now I ask myself, how many possibilities are there for that first place? Well, there are 14 because there are 14 boats to choose from. Now for the second place, I only have 13 possible choices. It's because the same boat can't do the first and the second place. Then for the third place, I have only 12 possible choices. So I multiply them and I get 2,184. So there's my answer. Well, now let's think about this problem in a slightly different way. We are selecting 3 of the 14 boats without replacement, and the order in which we make the selections is important. So this is not the way that the boats actually take first, second, third places. We don't just randomly select 3 of the 14 boats. However, for theoretical purposes, we could think of it as though we are randomly selecting 3 of the 14 boats without replacement. Now, without replacement means that I select 1 boat for the first place, and then I select a second boat from the remaining 13, and then a third boat from the remaining 12. And the order is important because the first boat that I select will get first place, the second boat will get second place, the third boat will get third place. So this problem illustrates what we call the permutation rule, and the requirements for the permutation rule are that there are n different items available. And the word different there is important in this case. Here we have 14 boats and they're all different, so n is 14. We select r of the n items without replacement. In this case we're selecting 3 of them, so r is 3. And thirdly, most importantly, the order in which we make the selections is important. Any problem that meets these 3 requirements will fit this permutation rule. So now to calculate the number of ways to make the overall selections, we don't have to multiply things like we did originally. We can use this formula. We take n factorial divided by n minus r factorial, and that will give us the number of ways to make the overall selections. This number of ways is called the number of permutations, and it's denoted by NPR. So permutations can be calculated very easily. The formula is built into our calculator. You enter n at the blank home screen, then you select Math PRB, option 2 for NPR, and then you enter R, and then you press Enter. So in this problem, the number of selections would be 14P3, because I'm selecting 3 boats from a group of 14. The order is important. We see the command there from the calculator, 14 NPR3 is 2184, which is the same thing we got using the fundamental counting rule. Okay, let's look at another example of a permutation problem. The manager of a baseball team has already filled 4 positions in the batting lineup. He has 8 players left on his roster from which to fill the remaining 5 positions in the lineup. In how many ways can he select the order? Well, let's make a couple of notes here. We are selecting 5 players from a group of 8 because we have 8 players left and we're selecting them to fill the 5 lineups. And the order in which I make the selection is important because the first player I select will go into the first position, the second player will go into the second position, so on and so forth. Okay. So this is a permutation problem. The total number of ways to make the selection would be denoted by 8p5. Again, because we're selecting 5 from a group of 8 and the order is important. And there you see the calculator command and the value is 6,720. Okay. Well, let's look at another example which looks very similar to the previous example, but there's a slight difference which is very important. Annette has rented a summer house for the next semester. She wishes to select 3 roommates from a group of 6 friends. In how many ways can she make the selection? Again, this looks very similar because we're selecting 3 from a group of 6, but let's note here that the order is not important. The first friend that I select is not necessarily different than the second friend that I select. Right? The group of friends of Shelley, Jane, and Marge is no different than Marge, Jane, Shelley. The order just is not important. So this is not a permutation problem. This is what we call a combination problem. A combination problem is any problem that meets these 3 requirements. There are n different items available. Here we have our group of 5 different friends. We are selecting r of the n items without replacement. Here we're selecting 3 of the 5. But thirdly, the difference between this type of problem and a permutation problem is that the order is not important. This problem meets all these 3 requirements, so it is a combination. We can calculate the number of ways to make the overall selection using this formula here. N factorial divided by n minus r factorial times r factorial. Notice this looks very similar to the previous formula we saw. The only difference that we have an extra r factorial in the denominator. This number is called the number of combinations, and it's denoted by NCR. Okay. Again, this formula is built into our calculator. You enter n at the home screen, you select Math PRB, then option 3, enter r, and then press enter again. Okay. So in this problem, it would be 6C3 because we are selecting 3 friends from our group of 6 and the order is not important. You see the calculator command there, and that is 20. Next example is going to look very similar to the previous examples, but there's a slight difference that makes it completely different. A group of 10 students consists of 8 girls and 2 boys. If they sit in a row of 10 chairs, in how many ways can their genders be arranged? Okay. Well, let's make a couple of observations here. First of all, the order is important because we're interested in the order of their genders. We're interested, is it boy, boy, girl, or girl, boy, boy, or again, the order is important. However, the items, in this case students, are not all different in terms of genders. Okay? They are different people, but they are not different genders. We have some of them that are alike and some other that are alike. So this is not a regular permutation or a combination problem because our items are not different. Okay? So this is a special type of permutation. And that's when some items are identical to others. So requirements that we have n items available and some are identical to others. That's exactly what we have here. Number 2, we are selecting all of the n items. So we're going to take all 10 students and select all of them and arrange them. And number 3, the order in which you make the selections is important. So we can calculate the number of permutations or the number of ways to make the selections using this formula. N factorial divided by n1 factorial times n2 factorial, etc. Where n is the total number of items, n1 of them are alike, n2 of them are alike, and 3 of them are alike, etc. So in this problem, n is 10 because we have 10 students. 8 of them are identical to each other, and 2 of them are identical to each other. So the denominator is 8 factorial times 2 factorial. And there you see how to enter this into our calculator. This formula is not built into the calculator, so we have to enter things manually. Now when you do this, make sure that you put that multiplication in the denominator in parentheses, because otherwise the calculator will not do proper order of operations. And the answer comes out to be 45. So there are 45 different ways of arranging these 10 students in order according to genders. Okay. Now what does this have to do with probability? Well, in example 1, we calculated that there were 27 different passwords to choose from. Let's suppose that we forget our password and we randomly guess it. What's the probability that we randomly guess the correct password? Okay. Well, according to Rule 2, the probability of an event is the number of ways that it can occur divided by the size of the sample space. Now this only applies if all of our outcomes are equally likely. Well, here we're assuming that we are randomly guessing the password, so all of those outcomes are equally likely. In terms of this problem, we're interested in the probability of the correct password. The number of ways it can occur would be the number of correct passwords. The size of the sample space would be the number of possible passwords. Well, there's only one correct password, and there are 27 possible passwords. That's what we calculated in example 1. So our probability is 1 divided by 27, which would be 0.037. So that means that there's a 3.7% chance that we randomly guess the correct password. So we see how counting problems are used here, or counting ideas are used. We can use them to calculate the size of the sample space. Our last example, we're going to do a real practical one. The Texas Cash 5 Lotto game is played by choosing 5 winning numbers in any order from the numbers 1, 2 up to 37. Find the probability of winning. So suppose we just randomly guess some numbers. What's the probability that's the correct choice, or the winning choice? Well, here we want to know the probability of winning. And then in terms of Rule 2, that would be the number of winning choices divided by the number of possible choices. Well, there's only one winning choice, so that's our numerator. Number of possible choices would be 37 choose 5. And that's because we are choosing 5 numbers from a group of 37, and the order is not important. That's what it said in the problem. Order is not important, so it's a combination problem. So again, we're using counting problem ideas to calculate sizes of sample spaces. Now 37C5 we can easily plug into our calculator. That comes out to be 435,897, and so there you see the probability. Notice that's a very, very small probability, as in the case in any lotto game. So to summarize, we have 2 different types of rules, permutations or combinations. And to decide which type of problem you have, you ask yourself, is the order important? If yes, then it's a permutation problem. If no, then it's a combination problem. That's it for the Section 4.7 lesson. The Course Compass homework is titled